Welcome to my workshop. Today, we're diving into the 4-bar linkage, a fundamental piece of mechanical magic you encounter every day. It might sound complex, but by the end, you'll spot it everywhere. We'll break it down from scratch, no prior knowledge needed. Think of this as your first step into making things move in useful ways. The 4-bar linkage is elegant, versatile, and shows how simple geometry creates complex motion. We'll cover what a mechanism is, introduce the 4 parts of our linkage, and explore how changing their lengths changes the motion. We'll even touch on Graashoffs Law, a simple rule to predict movement. By the end, you'll have a toolkit for understanding this essential engineering concept. So let's get started and see how 4 simple bars can unlock a world of motion. Let's begin. So, what's a mechanism? Simply put, it's a set of parts connected to control motion. You apply force to one part, the input, and the mechanism transforms it into a different output motion. Take scissors, 2 blades joined at a pivot. Squeeze the handles and the blades shear. Or a doorknob, turn it and the latch retracts. The rigid parts are called links. The connections are joints. By arranging links and joints, you can create endless types of movement. This is the foundation of all machines, from robots to car engines. Mechanisms are the skeletons of machines, turning simple power into useful work. When we talk about the 4-bar linkage, we're talking about a special team of 4 links. Let's meet them. Here's the star, the 4-bar linkage. 4 links, 4 joints, forming a closed loop. Imagine a movable quadrilateral. The 4 parts are the frame, fixed, the crank, input, rotates fully, the rocker swings back and forth, and the coupler connects crank and rocker, moves in a complex path. The coupler's motion is where the magic happens. Its path can be surprisingly intricate. Turn the crank, and it drives the coupler, which moves the rocker. Change any bar's length, and the whole system's motion changes. This setup is a powerful way to convert rotation into oscillation or vice versa. The 4-bar linkage is the workhorse of mechanical design. Its simplicity hides its versatility. It's the foundation for countless machines. Understanding it lets you design and analyze all sorts of mechanisms. Let's see how to predict its motion. Enter Graashoffs Law. Graashoffs Law is your shortcut for predicting 4-bar linkage motion. Here's how it works. Find the shortest, S, and longest L links, then the other 2, P and Q. If S plus L or P plus Q, at least one link can rotate fully. If not, all links just rock back and forth. This lets you classify linkages. Fix a link next to the shortest. Get a crank rocker, like a windshield wiper. Fix the shortest link. Get a double crank, like train wheels. Fix the link opposite the shortest. Get a double rocker. If S plus LP plus Q, you get a triple rocker, no full rotations. Graashoffs Law lets you design the motion you want before building anything. It's a simple rule with huge impact. Now, let's spot these linkages in real life. Once you know the 4-bar linkage, you'll see it everywhere. Windshield wipers. A motor spins the crank, the linkage sweeps the blade. Construction equipment. 4-bar linkages control the precise movement of buckets. Hand tools like bolt cutters use compound linkages to multiply force. Adjustable desk lamps often use parallel 4-bar linkages to keep the lamp head level. Even your knee joint acts like a 4-bar linkage, guiding complex motion. The same principle works at every scale, from tiny toys to massive machines. The 4 bars geometry gives control, precision, and mechanical advantage. It's a universal solution for turning simple motion into something useful. Nature and engineers both rely on it. Once you spot it, you'll appreciate the cleverness behind everyday motion. Let's talk about why this matters. Mastering the 4-bar linkage is like learning a basic chord in music. It's a building block for countless designs. It teaches the relationship between geometry and motion. For engineers and makers, it's the first real taste of designing mechanisms to do specific jobs. It's simple enough to learn, but powerful enough to solve real problems. Knowing how to design and analyze a 4-bar linkage is essential in fields from robotics to automotive engineering. It saves time, prevents mistakes, and leads to elegant solutions. The beauty is in its simplicity. 4 bars, 4 joints, endless possibilities. Don't just read about it, build one. Experiment, see Graashoffs Law in action, and feel the motion. Once you get it, you'll see the world differently. The 4-bar linkage is a true superpower for any creator.